Welcome back. So once again, we're going to be working on some free body diagrams for your body. We'll be solving them this time, though I would strongly suggest that you try. Kind of jumping ahead then, but hey, why not? These are good examples. So we have a free body, or you have a bar, which for some strange reason is just balanced perfectly um, in this strange little gap. We got a 300 Newton force down here, gives us a whole bunch of dimensions, and the problem doesn't say anything, but this bar probably has mass, but it doesn't tell us what the mass is, so we would have to neglect it unless it's told to us. And it says, okay, I want you to tell me, give me a free body diagram of this smooth pipe, which rests against the opening here. It has points of contact at A, B, and C. Notice that points of contact, not lines of contact, not areas of contact, points. Other thing, this is a smooth pipe, which means there's no friction. So how do we do this? Well, the next page shows you the answer, so let's just look at it together and see. First off, anytime you have one of these guys touching, it is always perpendicular to the surface. So this right here touches at a point. The force is going to be perpendicular to this surface. Right here, it touches at a point. The force is going to be perpendicular to that point. It's going to be right straight up from that point and straight down from this point. And let's look at the next slide and see how I did. And so you see right here we have an idealized model, which just shows everything. In this case, there's not a real picture, so the idealized model is just what we had. And then I'm correct. You see that these two forces were just straight up and straight down. Now you might be a little bit confused, like, well, this surface was at an angle, and that force was at an angle. Why are you perpendicular to the bar here, but to the surface here? And it really just depends on how the things are touching. So you really have to think about it that way. This is a long, flat surface, and so it's going to be perpendicular to this, while this is just a point. It's a point. So however this surface is lying on it, that is going to tell its orientation, the orientation of the force. In this case, I have just a point pressing on this, and so it's the long, flat surface that tells me, that directs the force. So whichever one has the longer, flatter surface, that one directs the force. That's the big kind of strange thing here that might throw you off. So this problem looks pretty hard, but it's actually fairly simple. You should remember that the long, flat surface is the one that your force is going to be perpendicular to. We're talking about a reaction force. Okay, let's go ahead and do the second one, because with free body diagrams, you really don't just take too long to look at them. So we've got a whole lot going on here. We have an applied moment, couple moment right here. We have a rounded, more or less a rolling support right here on this plane. We have a 100-pound force, and we have some sort of smooth coupler right here, which is sliding along this bar, which we are given the slope of as well. It says, draw a free body diagram of the bent rod supported by a smooth surface at B and by a collar at A. Now, let's think about this. First off, idealized model would look just like this. On our free body diagram, we would have to cut right here through that to show where the force is going to be that's holding it in place. We would also get rid of this ground and just replace it with a force. So let's look at that. And that's exactly what we do. Now, here is something that you might have forgotten about slopes. You see how this is rise or run, so 4, 3. Over here, though, we have it perpendicular, and it's rise over run, 3, 4. If you have a slope triangle, it is the inverse, the negative inverse of that slope triangle is the perpendicular direction. So in this case, you see that the run is going backwards. So this would be technically 4 over negative 3. That's the slope. Or, if you know, I look at it, through negative 4 over 3, because it goes down 4 over 3 from going from left to right. From left to right again, you see I'm now 3/4. So I was, write this down, I went from negative 4/3, I inverted it and times it by negative 1. So I reverse it, which gives me negative 3/4. And then I multiply by that negative 1 to give me 3/4. So that would be the perpendicular direction if you're given a slope. And the same exact thing happens over here. We have positive 5/12. We flip it, and then multiply it by a negative 1. So we're going to be going down 12 and over 5, which is what you see happens right here. So both cases it works, and you get the answer. Just be very, very careful about these. The slope triangles seem like they're going to be easy, but in many cases they can slip you up if you're not used to solving problems like that. Well, with that, we're done with this section. We're going to move on to next time actually solving some of these problems using our equilibrium equations. So I hope this helps you. I'll see you all next time. Bye-bye.